Sorry, still keep talking for a minute. We'll give it a minute. Things off. Just check with Doles on the sound check. We're looking good. Live streaming to at least a dozen people, which is always good. I feel very nervous in front of such a large audience. Thank you very much. For those that have come in and just doing today and registered, appreciate your support. Thank you very much. Today's day 2, the last day. We'll finish a little earlier today, but we've got a heap of really awesome talks and stuff lined up, which is good. Housekeeping side of things, so for those that are new on, for those that were here yesterday, you've heard it already. Red shirts are your friends, so if you need some support from anybody for anything, just find somebody in a red shirt, give us a tap on the shoulder and we will help. Unless it's for the physical CTF and you're trying to find the access cards that we've got hidden around, in which case we'll be deliberately obstructive and painful and make it difficult for you. Good luck. Emergency evacuation, you'll hear the whoop whoops on everything. We'll give you the nudges. Evacuation is out onto the grassed area outside, but just be super calm. These buildings don't go up in a couple of seconds. Just take your time, follow the crowds, head outside, stay safe. Bathrooms and breakout areas. Straight outside, hit a left, down the stairs, there's bathrooms. There are more accessible bathrooms down to the right-hand side. There's a prayer room as well if you need it, just down there to the side. Thanks to Tess and Hannah. They are running the coffee truck and that for us. Free coffees today, free yesterday. It's pretty good coffee. Enjoy, say thank you. Lunch, again, we'll be hitting Mac Daddy's for the pizza today. Similar kind of timing. I think for those that were here for the last conference and there was a bit of a gap between the 1 and the 2, it seemed a lot better yesterday. All good, yeah, it's really good. It's awesome pizza. Thank you. It's really easy to get this place in an enormous mess when things like the pizza come out. We will never again do the Krispy Kreme sugary glazed donuts as we did before. That was an unexpected cleaning cost afterwards, getting glazed sugar out of the floor, but we won't do that. Pizza was great. Everyone left it super tidy. Boxes were all in the skips. The bins were all full. Everybody was massively respectful, and we're grateful because we have to do the cleaning up, nobody else. So appreciate that. Schedule is online. If you want to see that, head to the B-Sides Perth website, hit the 3 hamburger bars at the top, go to schedule, go to the Prattle X kind of link, and you'll get everything. It's up on the screen here if anyone's not seen it. Massive thanks to our sponsors. B-Sides Perth has always been really transparent in sharing its financials at the end. So when we do the close later on, you'll see just how close we were running this year's conference. If it wasn't for our awesome sponsors, it wouldn't happen, or it may happen, but in a much more cut down form where you wouldn't get things like lunches, coffees, those kind of bits. For anyone that's ever been based out here, it is super difficult to walk anywhere and get food or drinks or anything else. You're kind of a little bit isolated. So the fact that we can put this stuff on and keep you as a captive audience is amazing, and we thank people. UWA, our venue sponsor, they've helped us out for the 6 years that we've been running this massively, and they've probably got the biggest, most closed facility for us to be able to use with this lecture theatre. The other one when we've run 2 tracks in the past, and all the breakout rooms for people that just want to listen in on the live stream, do the CTFs, play with badges, those kind of things. InfoSect, massive thank you to them. They got in early, helped us out. That kind of funding early on from a silver sponsor helps us do things like lock in the venue. For anybody that runs a conference, locking in the venue is the most important thing, because then it's real and everybody else hangs off the back of that. If you've got a venue and it's paid for, it's happening. So that's a massive step up for us. Horizon 3, go and have a chat to them. They've got a booth in the lobby. Say thank you. You'll see just where all the funding that comes in from the sponsors goes when we share the financials later on. And Securo as well. They really helped us round things out. Equally, they've got a booth. They've got people here from Briz, from Melbourne that have come over, so say hello and a thank you. And all the supporters. I'll share the details later, but one of these came in a week ago and actually helped us, and that was the difference between being able to do the food and the coffees and all the other bits or not. So say thank you. And if you see a red shirt, say thank you. All the volleys and ourselves are all totally unpaid. We do this for the love of kind of pulling everyone together, starting good conversations. And it's the same crew. You'll recognise the same faces as the most reliable red shirts that just rock up. Snades, when you see him, he's like Michael Bublé, comes out at Christmas only. He comes out for B-Sides Perth and you never see him for the rest of the year, but totally solid, and we thank everybody that's up on this slide as well. The badge, there's a lot of fun with the badge. So there are still component packs. We saved some by for people that only register on a Sunday. If you want to grab some components, build your badge. The reason that we did it like this is you have a shiny little badge that doesn't scratch people because it hasn't got the components all stuck on it. There's always a lot of talk about, is it just unnecessary e-waste? So we kept it kind of fairly slick. But equally, there are a lot of people that want to play around, learn soldering, learn coding, those kind of things. So lots of badges, smaller number of component packs. If you want to build and hack the badge, do it. All the source code is up there. We can do those things. Aside from that, we will have prize winners and bits announced later. I won't go through all these slides because it's got the details on of some of those winners. Say thanks to Tim that built the badge, all the usual stuff. Aside from that, and seeing if I'm on time, I'm going to hand over to our first speaker of today. Louis, many of you will know Louis, owns and runs Pentester Lab. Many of you will have used the kind of training, educational stuff that's on there and learnt a heap of things. Louis has been a huge supporter of B-Sides Perth since the very first one. Always kind of comes good, and we really appreciate his support over the years. I'll introduce him to talk about those who don't learn from CVEs are doomed to rediscover them. Louis, come set up. Yeah, go.
Okay. Oh, yep. Oh. Yeah.
Over to you. Thanks, Louis.
Can you hear me okay? Yeah. Okay, cool. Good morning, everyone. Thanks for waking up so early after last night. It may be hard for a few people, especially since we're going to talk about source code. But basically, so my name is Louis. I run this website, Pentester Lab, where I train people. And to train people, you want to have good content. And as part of finding good content, I need to look at a lot of CVEs. A lot of CVEs. And I call myself like a CVE connoisseur or a software entomologist or even like a CVE archaeologist. I love looking at bugs. I don't know why, just like I found that very appealing and I've been doing that for a lot of time. It's kind of a weird hobby, but I'm gonna try today to convince you that it's a great thing to do if you want to learn new things. As part of that review of CVEs, I came across recently this CVE, CVE 2025-54887, which is a missing AES GCM authentication tag validation in encrypted JWE. I know exactly what you're thinking right now. Crypto on the first slide of the first talk of the second day. Yeah, let's see that pay off. I know, it's hard. We're gonna get there. It's only an hour. You can go for it. So when I saw that CV, I was like, oh my God, this is amazing. For a few reasons. I love JWT, love JWT. I did a talk here about JWT, I think, 5 years ago, like pre-COVID. That's how much I like it, and I still love them. I love Ruby, and that's a bug in a Ruby library, so oh my God, that's amazing. And I kind of like crypto as a friend, like not So yeah, so I'm going on an adventure. If you don't know the reference, that's from Harry Potter. I saw your hat. So yeah, I'm going to do the same joke in New Zealand. I'm going to get killed. So GCM is this encryption mode that you can use to encrypt data. And if you compare GCM to other modes, like ECB, CBC, it's a lot better because GCM gives you encryption, like all the other modes, because you want to encrypt data, right? But the important thing is that GCM gives you authentication, meaning that if you tamper with the data, it's not going to get decrypted. So it's really, really good because a lot of attacks you can do against crypto is around manipulating data and getting that data to still get decrypted. Even if you can't make sense of what is in the data, you can still tamper with it in a way that will trigger unexpected behaviors. So let's look at GCM. So here we have our GCM, and it's only boxes. You don't have to understand the details. It's pretty boring. Yanak, I'm not a cryptographer. I'm just an enthusiast. And so if we add here IV, so the nonce, the thing to initialize the encryption or the decryption, if we change that to VI, because everyone loves VI, and if they don't, they're wrong. If we do that, right, I'm glad we agree. If we do that, the decryption is going to fail. It's going to get rejected, right? Because we tampered with part of the information that is used to feed GCM. And that's where the authentication tag is so important. If we try to modify the ciphertext, and we change it to ciphertext, again, it's going to get rejected because we tampered with part of the information, so the authentication tag is here to prevent that. If we change the tag, the authentication tag at the bottom here, we change auth to AA2, again, it's rejected because we tampered with some of the data used to do the decryption. But what if we change auth tag to just A? Approved. So it's not in all implementation, but some implementations have these issues. And so since we can just use 1 byte instead of the full authentication tag, that is usually like 16 bytes nowadays, what we can do now with only 1 byte is try to modify the ciphertext and go back to this ciphertext. It's going to get rejected because the authentication is only 1 byte, but it's still there. So we keep going. We move to, what did we do? Oh, instead of changing the ciphertext, we change the auth tag from A to D. Again, it's get rejected, but if we do that for long enough, and we go, for example, with T, we may get lucky, and it's going to be approved. And so we just need to brute force 256 combination, and we're good, and we can start modifying the encrypted data and trigger unexpected behavior in the application. I didn't know where to put the next slide, but I think it's pretty good. So, and I came up with that idea. So, signs of a stroke, twisted mouth, RM paralysis, incorrect speech. I had to use it. Sorry. And if you ask, for example, ChatGPT to write a bit of decryption in Ruby and to say like, oh, we want to use GCM, they're just going to use the auth tag as it is. And the problem is that we have this GCM tag truncation attack. So that's not in all languages, it's only in a few lucky ones. One of them being Ruby, as we saw. So when you think Ruby and you're like a Ruby head like me, you find that you say like, oh my God, I know something that is using GCM. That's Ruby on Rails. So I run to the GitHub source code of Ruby on Rails, and I start looking at the code. And as part of the code, there is this little comment saying like, okay, here we check the size of the tag because there is this issue that we know of. And I've been doing Ruby since 2005. I've been doing a fair bit of AppSec, crypto, and I didn't know about this. Anyone knew about that, actually? Hands up? No. So I'm not the only person. So yeah. So there's this message saying like, okay, we want to check the auth tag size because otherwise people can brute force it by just using 1 byte instead of the full 16 bytes. So there's a link. I clicked on the link, and I go to an issue in Ruby/OpenSSL because the point is that Ruby is trusting OpenSSL, and OpenSSL is only is trusting the auth tag you give it. So if it's 1 byte, we check 1 byte. If it's 16 bytes, we check 16 bytes. And that's an issue that is open since 2016, which is not great if you're in software security. No, that's my opinion. But thankfully, so that was in July, it's a bit small. But in August, someone like in good faith decided like, so since it's hard to fix that bug, let's at least add some documentation. So they did that in August to say like, okay, let's at least warm users. Let's at least warm developers. So they had that, and that's the documentation of the OpenSSL cipher in Ruby, and that's the documentation here. So that's why you need to read all the documentation all the time. So that's Ruby. PHP has exactly the same issue, but at least it's a little bit better in terms of documentation, is that you can see it pretty quickly. But same like in Ruby and in PHP, your auth tag, if you provide 1 byte, it's going to check 1 byte. So that's a good way to brute force things and to find like unexpected behavior in applications. Now, we did Ruby, we did PHP, let's move to Node. Node had an issue about that in 2017, and it's closed now. So we're good, right? And the thing with Node is that at the time, it was only checking 4 bytes. So a bit better than 1 byte, but still 4 bytes instead of 16, not great. So that issue is closed. So as a software developer, as a software security engineer, you expect that to be fixed. No, that issue has been reopened last year, saying like, okay, we still had 4 bytes, and that's not great. We should check like at least 12, or making it hard to brute force the values. So it exists in Ruby, PHP, Node. So what can we do about that? So I took my like white hat on, I put it on, like white hat Louis. So I like to call myself when I do like good deeds. And I looked at other Ruby code bases and see if I can find the same thing. And I found one named Reforge, where I contacted them like 2-3 weeks ago, and they got it fixed. Then, and that's something that is amazingly easy to do with AI nowadays, with like LLMs. I asked Claude or ChatGPT, I don't remember which one, but like, give me that same code in other languages. And LLMs are amazing at doing that. And I found the same issue in Erlang, Elixir, because Erlang, and Lua. And Lua, they didn't get back to me, but Erlang, at least they updated the documentation. And then another thing I could have done, but I didn't do, is look at over encryption mode to see if I can find the same issue. But regardless, I worked on making the world a better place, one code base at a time. And that issue really made me think about all those bugs that have been around for a long, long time, or have been around in some code bases, and then they disappear and then come back. And I start looking at all these kind of bugs that like kind of happen, then we forget, and then they come back. And there are like a lot of examples of that. We had HTTP proxy, but basically HTTP proxy is when you have CGI, So CGI is like a way to run application that people are not using for the past 10 years, but somehow that kind of bug reappeared. And it was something that was pretty big in 2001. And then no one talked about it for like 10 years. And then it came again in 2016 or 2015. And we have this cycle of like, okay, everyone is talking about it, everyone is fixing it, and then everyone forget about it, and it comes back. The same thing happened with zip sleep. You have like CVE around like .. in zips, so you have like a zip file at the top here, malicious.zip, where we just have a zip that contains a file that is named .. etc passability, and if we unzip that file with a vulnerable application, that's going to override potentially etc passability. So that was an issue in 2001. And no one talked about it until 2018 when like the Sneak team did like a nice website with zip sleep, very dangerous, and they rediscovered the issue. And they're very public about like, it's not a new thing, but like they realized that it's not a new thing, but everyone forgot about it, and now it's back. And if you look at a lot of code bases written in Golang, it's everywhere, like everywhere in Golang. Another bug that was kind of the same way around this is Unicode character in password reset. So if I have an email address, louis@github.com, with a nice I, like git, a nice I, someone can use a reset password, and instead of writing github.com, they write github.com, but they use a Turkish I that doesn't have a dot. And then when you do the string comparison with the database, most of the time it's going to be string case insensitive, so it's going to get the email address, my email address, louis@github.com with a normal I, like a classic I. And that can allow them to reset my password. So that was a thing in November 2019 in Django. Then, in GitHub. Then someone reported the same issue in Django a month later. And nowadays, you can find people like rediscovering the same bug. That's in Node codebase named Directus. And again, the same bug again. Same thing with SAML, where we had signature wrapping in 2005. A lot of people were talking about it, like SAML is terrible. And then no one talked about it for a long time. And in 2012, a lot of people started rediscovering the same bug. And then no one talked about SAML for a while. And then in 2017, Duo did some really good research around like injecting comments. And then no one talked about it. And 2002 this year, it's pretty crazy. Like SAML security is back on. And the research we're doing is a mix of signature wrapping and the XML comment from Duo. So we have like this cycle of like, okay, everyone talks about it, everyone forgets, and then it's rediscovered. And the most interesting thing I saw about that is, this is a podcast, Critical Thinking, and this guy here with the beard is James Kettle. He does a lot of web research. He's probably one of the most well-known web security researchers at the moment. And he was talking about the exact same phenomenon. Like people are doing research, everyone is talking about it at Black Hat conference, it's crazy, and then everyone forgets. And then the issue gets rediscovered again. And I'm quoting him saying, the best example of that, this that I have is request smuggling. So a lot of his research was around request smuggling. And basically, he took a white paper from 2004, and I think he did that in 2012 or 2013, like something like 10 years ago maybe. And he copy-pasted a payload from that white paper from 2004, run it against Akamai, and own the hell out of Akamai by just using old research. And that's what he's explaining in that podcast. Is like, people forget about stuff, and then they re-implement the same issue, and if you like wait for long enough, you can own a lot of people pretty easily. Because we have all this cycle of like, oh my God, it's vulnerable, the world is on fire. Then everyone forgets. And people forget, so the security community forgets, but also like all the developers forget. So because as a security community, we don't talk about it anymore. And then there's a rediscovery, and we're back to the, oh my God, vulnerable. So that's why I think it's a really good reason to look at CVEs and to talk about those. So let's see how we do that. The best source of CVEs nowadays, especially if you want to do that kind of fun work, is a GitHub advisory database, and they're publishing every day of the week new CVEs. And the good thing about that is that you can pick your language. You can pick your severity. Oh, I only want cool bugs. I want critical and high. You can also pick the CWE, so the root cause of the issue. I only want to look at critical directory traversal in Golang. You can filter by that and look at that. And look at the source code. And I just picked one randomly. That was an authorization issue in Go 0. Once you've done that, what you used to have to do is git clone the repository, then look at all the tags to find the version you're looking for, because you need to find the vulnerable and the fixed version. And then you do a bit of git diff between the vulnerable and the fixed version. You keep going until you find something. And if you're lucky, you're going to find the bug, and it's not going to be like 20,000 lines of code to review. It's just going to be like a few lines. So that was what I used to do, which was a lot of fun. And nowadays, GitHub has people who report vulnerabilities and people who fix vulnerabilities to link to the commit of the fix. And that's what we can see here in the second line. And this is amazing. As a security person, you have exactly what was changed. You don't need to search for hours. You don't need to spend like hours in the source code. You just like, click that button, click it, and you got the result. Great success. And so that's exactly like, that's just picking one of the advisory in the list, finding that there is this button with the commit, and clicking on that button, and you see that. And that's, yeah, just like, okay, people fixing a bug. So we can see what the old version of the code looked like, and we can see what the new version of the code looked like. Very, very easy. So what they were doing is they wanted to allow an origin, so just like a domain or a host name, and all subdomains. And that's what they wanted to do, and that's what they meant to do. What they actually did is they allowed host name ending with the origin, because they didn't have the dot before the allow. So basically, if you want to protect Pentestalab, if you were allowing pentestalab.com, you were also allowing hacked by pentestalab.com or whatever the hell you want, pentestalab.com. Once you've done that, a really good advice is to document what you found, because this way you can quickly look at it in the future, because like memory is something that goes away pretty quickly nowadays, at least for me. So you can document that and keep the version of the code before and after, and this way you have references if people ask you about like, oh, what's the common issue with Golang? And you can come back to that. And that's something I do, I would say, on a daily basis at the moment. And because you learn so much, you learn so much. You learn about traps, things that are misleading, things that developer will not understand properly. And you can see as well, since you have a lot of CVEs, you can really see like, okay, what are the common mistakes they're going to make? For example, in Golang, if you love Golang, there is a function named path.clean, which developer think will prevent directory traversal. It does not prevent directory traversal. It clean, as in it normalize the path. So if the path starts with a slash, it's going to remove the dot slash, but if the path starts with dot slash, it's not going to remove it. And you can also find patterns. If you look at a lot of CVEs, you're going to identify patterns of like, okay, people tend to get that wrong all the time. And the last one is your like spidey sense. Is like, the more you look at that, the more like your spidey sense will be tingling when you look at bad source code. So let's look at an example of trap. We're going to talk about the best programming language in the world, Ruby. Yeah, okay, we all agree. So in Ruby, you have file.open/etc/Debian version, and you do .read, and that's going to read the content of etc Debian version. You also have a shortcut named open, and we do open/etc Debian version .read, and we get exactly the same result. The thing is that that shortcut is not file.open, it's kernel.open. And if you do open and something that is user-controlled, so fully user-controlled, you can get the content of any file on the file system. Woohoo! which is obvious. It's used to open files, right? Now, if you are old school and you remember your Perl days, Perl had something really cool around opening files. And Ruby has the same thing. If the file name starts with a pipe, Ruby and Perl are going to execute that as a command. Not with file.open, but with open, they're going to do that. It's going to do that. So you go from like reading arbitrary files to code execution, which is a pretty good win if you're attacking applications. So that's the kind of traps you can come across. Another thing is patterns. You're going to see the same, people doing the same mistake again and again and again. And that's probably one of my favorite patterns, is here we are Java developers, loving life. We do like, okay, we want to prevent people from uploading malicious files. We want to prevent them, I don't know if you can see my mouse, we want to prevent them from uploading GSP or GSPF files, because otherwise they may get code execution. So we prevent that by making sure that the file name doesn't end with .jsp or .jspf. That's what we do here. And we throw an exception, dangerous extension. So that's our filtering. So maybe good enough, may not be good enough, we don't care, we're not going to talk about that. But after that filtering, what we do is we modify the file name. And that's a common pattern you can see if you look at a fair bit of source code, is this filter and modify. And when you look at that, your idea should be like, okay, can we bring back what was filtered using the modification? So here the modification is removing all those bad characters, hash, double quote, semicolon, square bracket, whatever. Like we want to remove all of those. What we can do is we can leverage that modification to reintroduce something that was filtered. For example, if we submit hack.jsp with a hash, that's going to bypass the filter because it doesn't end with JSP. But then we go to the modification and the hash at the end will be removed. And we go back to hack.jsp. So that's the kind of neat trick you can learn. You can also find trends. And that's really like, that's 1 hour of writing Ruby or 5 minutes of ChatGPT. Is you go through all the CVEs that in one language and say like, okay, give me extract from the JSON file the CWE, so what's the root cause? And you can see over time what is happening. And you can see, okay, if I have a Golang code base, what are the bugs that are the most likely? So probably XSS, path traversal, and denial of service. So if you're like a code reviewer or if you're like a pen tester, you can say like, okay, I'm going to review a lot of Golang. What should I spend my time on? What is the most likely what's the most likely vulnerability? If you're like, you're part of the blue team, you can also work around like strategy to make a Go code base more secure, because you can say like, okay, every time we have a Go code base, there is a directory traversal because it's very common. What can we do about that? And same thing if you want to scale security. You can also look at all the critical and the high, because you can filter by severity and say like, okay, what are the most common severity in Golang? And so this way, you know, like, okay, we don't care about all the vulnerabilities, we want only to cover the big one, like the big impacts. And here we have one new issue, command injection that start appearing in 2025 in Golang. Any idea why? MCP. MCP server love to run commands, so we can see that in 2025, all of a sudden we have command injection coming to our list of vulnerability for no apparent reason until you think about MCPs. And you can also compare different languages. What is the issue? What is the most likely issue in Golang? What is the most likely issue in Python? You need to be aware that there is usually like a bit of a timeline between the time when people find the bug and the time you have access to the vulnerability. So you're like a bit behind. And in the same way, we have deserialization coming to Python in 2025 for no apparent reason. LLM love deserialization of things. So you can see those trends that are really interesting. Since you are all convinced now that looking at CVE is amazing, we're going to look at CVEs. So this one is in a code base named Juju from Canonical. Canonical is like Ubuntu, to simplify it. And we're going to start with a bit of an introduction. Those are 3 ways to compute a SHA-sum, so a hash of a string, hack the planet, in Golang. And we're going to play spot the imposter. So we have method number 1 here, where we get the data, we copy it, and then we get the hash sum, and then we print it. We have method number 2, where we do something that is a bit shorter, looks a lot nicer. And we have method number 3. So who thinks the imposter is number 1? Who thinks the imposter is number 2? Who thinks the imposter is number 3? Ah, nice. Who doesn't care? Thank you. Thanks for your honesty. So basically, it's number 3. So if we run that code, the first 2 will return the hash of hack the planet, which is really great. The third one, not so much. And because the function sum, and so if you go back to the code, those 3 snippets look a lot similar. But when you run sum and you pass an array of bytes to the sum function, it's going to add that to the hash before, like it's going to prepend that to the hash. So the last one, the last hash is a bit longer because we have hack the planet in clear text followed by an empty hash, a hash of an empty string. And you may think that's never going to happen in real life, right? That's exactly why I'm here. So that's a CVE from 2025, so very recent again, 2025-6224, where this code base, Juju, they are creating certificates with public-private key, and they like generating that using Golang. And as part of that, they call this ED25519 with generate key, and that's giving this public key that they're ignoring here with the underscore, then a private key that they name key, and then an error. They check the error, blah, 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 and then they create a template to finally create the certificate. To create the template, they call method number 3, the one that leaks the content of what we are trying to hash. And so basically this vulnerability is nothing short of amazing, is this code is generating certificate with the private key in clear text as part of the subject key ID of the certificate. Yeah, like the thing you come across, it's magical, right? And it gets better, it gets better. Wait. Hopefully I'm not running out of time. And this vulnerability was introduced in 2024 in June by someone from Queensland, classic Queenslander. Actually, I like to joke about it, but this person got very, very unlucky. Like, it's not normal that by using a function, like code that looks all right, they end up with something so bad. But yeah. And what they did at the time is they wanted to move from ED25519 to, from RSA to ED25519, and they changed the code a little bit, and they said like, okay, the generate key for ED25519 has a third argument, so we're going to ignore it, but that's a public key. And when they generate the hash, instead of using key.n, which is public for RSA, they use just key, but key is a private key. So very unlucky. On top of that, the subject key ID, so the field they use to put the private key, you don't need to do that anymore. That code is not needed since Golang 1.15, which was released in 2020. So they wrote code for something, and they introduced like a terrible bug. Not their fault, because they got very unlucky, but for code, something they didn't have to do. And I think there's a good lesson to learn here. So first, error proofing, it shouldn't be that easy to get things wrong. Then when you do code review, check ignore return values. Here they're ignoring the public key. So maybe they should have not ignore the public key and use it. The name of the variable matters. Like if you name something key and it's a public, private key, it may bring surprises in the future. So be aware of that. And every time you change something, is this code still needed? That's probably something we don't do as software developers and as security person, is that we have code, we change it, but maybe it's not needed anymore. And removing code is a lot more important than updating code. The less code, the less problem. Another bug I really like, and that's the first vulnerability I publicly wrote about in 2008. It's a flow in WordPress. WordPress is a blogging system, and they allow people to log in using that function, WP validate cookie. And that's a lot of PHP. They get the cookie, then they split it in 3 parts based on a pipe characters, then they get the username, an expiry time, and a signature. And basically, if you don't have the, like GCM, if you don't have the right signature, you can't go through. They check the expiry, that it's not expired, they check a lot of things, then they check, they compute like a hash on their side, and then they compare the hash they have on their side with the hash from the client. And if they are the same, you're logged in. If they are not the same, you're a bad hacker, you don't get logged in. And this bug is nothing short of amazing. So that's what a cookie will look like. If you are admin, you got admin, pipe, expiry, pipe, and your signature. And we're going to split that in 3 parts, and then we compute a HMAC with a secret, and we compute the secret of admin and the expiry. And all is good, everything is working well. Now another user comes in. This user is logged in as admin1, and they got a cookie where it's admin1, the expiry, and the signature. We can't forge the signature because we don't have the secret, but what we have is that the code will split in 3 parts, admin1, the expiry, and the signature. And we compute the hash or the HMAC of admin1 and the expiry. And that's where it gets really cool, is that if I'm logged in as admin1 with that expiry and that signature, I can be a bit naughty and move the 1 from admin1 to the expiry. And then the code is going to split in 3 parts, compute the hash of admin, that new expiry, and using the secret. And then that's the HMAC of admin1 with that long expiry. So the one we had initially is exactly the same as the one of admin with that longer expiry, because we have a collision between 2 values. And that's, yeah, at the time that blew my mind. And now they fixed that, they just added a pipe because what the problem was is that there was no separator between the username and the expiry. And lesson learned, and I think it's important to do that every time you look at a CV, is like, okay, always include like an expiry when you sign something, because you don't want to sign something that is valid forever. Always use a separator between value when signing. And also as an attacker, people tend to think that if something is signed is tamper-proof because they don't know how to break the crypto. You can break crypto without knowing anything about crypto, trust me. And yeah, another one, PlayStation injection that was found in 2013, officially by the National Australia Bank, NAB, unofficially by me. And basically, they have a session management that looks a lot like Ruby on Rails, where they have, again, signed session. And I'm 500% sure I wouldn't have found this bug if I didn't study the one we just saw in WordPress. And basically what they do is, so for the story, I was like reviewing like 5 different implementation of session in Java, as you do. And it's really good. Like if you're not good at something, don't look at one code base. Look at 5 code bases and compare them. Play, spot the difference. So much easier. And that's the code that is used to parse the session. So basically, you give, no, that's the code that is used to generate the session. So you have the session in memory and you want to create a cookie. So what they do is they basically concatenate a null byte, key, a colon, value, null byte. And they keep doing that for every key value in the, that's a hash map. And basically, if you're a code reviewer, you look at that and you think, okay, they are reinventing a serializer. If you want to do that, you use JSON, you use YAML, even use XML. What's better than that? Don't record my, oh, that's recorded. Anyway. And what is happening is that we have key value, key 1, value 1, key 2, value 1, and we end up with key, null byte, key 1, value 1, null byte, key 2, value 2. And if it's Louis and Louis at pentasa.com, we end up with something that is very similar. Now we look at the other way around. When we go from that cookie, that big string with all the null byte that is very ugly, and we go from that to a session in memory. We have this weird regular expression, and then we loop through all the elements that we get when we match with that weird regular expression. Sorry, I'm pretty low on time. So, and what is interesting is that if we look at what is happening, we get, again, this way, the other way around, so it's a cookie with null byte, key 1, value 1, null byte, key 2, value 2, null byte. That's going to be splitted by the regular expression, and then we end up with session.put key 1, value 1, and session.put key 2, value 2. Everything is fine. And now I keep looking, and I look at the put function. And that put function that is going to be used to add your value based on the key. What they do, and that's what gave away the bug at the time for me, is that they check that the key doesn't contain a colon, because probably something broke or something like that, and they had to prevent that colon from happening as part of the key. So they add a filter for that. But they don't have any filter on the value. So as an attacker, you can potentially inject a null byte or a colon. And as an attacker, you probably have control over the value, not the key. So again, we are like a nice person. We're going to log in as Louis, because Louis is a nice person. You have to trust me on that. It's going to end up with session.put username Louis. Okay, we're good. And we have a cookie with null byte username, colon, Louis, null byte. Then not so nice, we're a bit naughty. We set our username to Louis, null byte, username, colon, admin. That's going to do session.put username and that weird username. Ta-da, what's going to happen? And then we get a cookie with that weird username and that whole that is happening right now with just this weird user with this weird username. But then we reload the page and the application, the framework needs to pass or session. And that's where the magic happens. It's going to split based on the null byte and the semicolon, the column. It's going to be username Louis null byte, and it's going to do session.put username Louis. And then it's going to loop one more time because we have more in the session, and it's going to do username admin and do session.put username admin. And it's going to overwrite the previous version, the previous value, and we're going to be logged in as admin even if we didn't have admin privileges or anything. And the really interesting thing is that looks a lot like the previous bug we saw, like around okay, we need to have a separator. What is happening if we don't have a separator, or we have a separator? What is happening if we can inject a separator? So, and if you keep doing that over time, you're going to build that knowledge, and you're going to know exactly what to look for. You may say, but those are lucky picks. So I looked at the bug. Admittedly, yesterday was a pretty good day for CVE. Like a really good day. So I looked at a few CVEs yesterday, as I usually do, and I came across a few bugs that were interesting. So one of them was an application, a shopping application, where when you purchase something, they log you in. And their goal was to make it easier for the customer. You buy something, and you logged in with the email that is used in the receipt you asked for, right? What ended up happening is that when they log you in, they either create a new account or look up the account in the database. So as an attacker, I buy something for $5. I put the email address of an admin of the application or anyone else, and I'm logged into the account. Yeah, that's pretty good fun. This one is absolutely amazing, maybe a bit small. That's in PHP. And basically, and that's from yesterday, Friday. They have a list of target value. You can't use those values, too dangerous, don't use them. And to make sure that you don't do that, they look up the value you provide
and they look up that into that list of bad values. Bad, don't use them. And if it's in the list, they throw an exception. And that's the change they introduced to fix that issue. So the vulnerable code is array search, and the fixed code is in array. So and it's always important to ask yourself, like, what did the developer meant, and what actually happened? And so what they meant is like, okay, if the item is in the denied list, we throw an exception. But what happened is that array underscore search return false if the item is not in the list. Otherwise, it returns the index of the item. In PHP, array indexes start at 0. And people are saying where it's going. It's good, hey? So PHP treats 0 as false. So the first item in the list is not blocked. Because if 0, throw an exception, so it's not blocked. I find, like, I may be a nerd, but that's beautiful for me. Like, that's amazing. Yeah. And so that's why Ruby is the best language in the world. Because Ruby, 0 in Ruby is an object, and 0 is true in Ruby. Because we thought about that. Take that, Python and PHP. You also find some good fun. So that was not Friday, but this week. So that's code written by an LLM in 2024, and someone reported a bug. That's like the YOLO of writing source code. Like, basically, when you want to parse JSON, people usually use a library like JSON.load or whatever, and could have security issues, but like, and this code that was, I think, written by an LLM, just do eval. So basically, eval that at source code, and if it's JSON, it's going to work. It's going to create a hash table, like properly in Python. But yeah, that's very, very dangerous. So you can find like good stuff like that. You can also find incomplete fixes. From time to time, you're going to be lucky, and you can even create good memes. So if you were like born in the 90s, that's an amazing joke. If you're born in the 20-something, it's going to be not as fun, but yeah. No one knows who Exhibit is anymore. Anyway, so you can find like incomplete fixes, like I usually find like a handful per year. So that's one where they actually decided to not fix it. They had an issue where people could bypass their directory traversal prevention using encoding and replacing ... with %2e. So this way you bypass the check on ... because you encoded the value. So what they decided is to decode the value once. So they actually blocked ... %2e because now it gets decoded at ... But they are overwriting the same value. So what you just need to do is instead of sending %2e, you send %25.2e, which is just ... encoded twice. And their fix decodes it once, and then the rest of the application decodes it once as well. I found another one this year where they had like, basically, as an attacker, you can add, you can purchase, it's like a shopping application, and you can, you get a token that you can use when you purchase something, and you can reuse that token again and again and again and again and again. So they fixed it by adding like, first they look up for the token, and then they update the token. So what they actually did is they didn't fix the bug, they just make it harder, or the windows of opportunity to exploit the race condition is a lot smaller, but it's still there. So I got them to patch it. I don't think they get issue a CVE for that one, but yeah. So that's what the code to fix it looks like if you're very curious. So they use one single query. So that's a lot of bad source code. CVE, looking at CVE is really good because you're going to learn a lot, but don't just look at bad code. I know a lot of people who try to get into code review, and they're like really unhappy when they look at source code for like a week, 2 weeks, 2 months, and they're like, oh, I didn't find anything. I'm wasting my time. What am I doing with my life? And a few of them are in the room, apparently. So, I think it's really important to look at good code and be aware that when you're doing that, even if you don't find bugs, you're not wasting your time. Look at it as building a baseline, accelerating future review. the more you look at good and bad code, the better you're going to be long term. And you're going to get really good at spotting not necessarily vulnerabilities, but things that are unusual, because you looked at a lot of good source code. And what I did recently, probably last year, is instead of trying to find JWT algorithm confusion attacks, vulnerabilities, I decided let's look at how people prevent that issue, which is basically exactly the same question, but just a bit like swapped around. And fancy way to trick my brain, like if you look at, for vulnerabilities in JWT libraries, it's likely that you're not going to find a lot of them. But if your goal is to say, like, let's see how people prevent those attacks, you're learning a lot, and you may find some bugs. And I think I found two. Yeah, I found two. One in Scala and one in C. It was a pretty good. But the thing is that you're getting a lot better as a code reviewer, and you're getting a lot better at, as well, quickly being able to triage source code, as in, we need to look into that. That's no way it's vulnerable, or that's totally vulnerable. So you get better over time if you keep doing that as well. So don't only look at bad code, look at good code, and if you do that, don't think of it as, I didn't find a bug, I wasted my time. Everything you, like time spent looking at source code is never wasted as a security person. Really, really. In the same way, a lot of people people who try to break into like security, or get into offensive security, people recommend like, oh, get a CV, it's really cool, get a CV. And it's good to have a CV, I totally agree. Like if you're new and you want to break into offensive security, getting a CV is really good. But it shows like to an employer that you can find vulnerabilities, you can understand how they occur, you can explain the vulnerability, maybe you even look at the source code, maybe you can talk about how they fixed it, maybe you can add the CV to your name on LinkedIn. I'm not judging, I am totally judging. The problem is that it's hard to find new bugs. Or what you're going to do is you're going to lie to yourself. You're going to look at shitty code base and find easy bugs. Because your goal is to not find cool bugs or learn, your goal is to just find a CV. So let's pick the weakest code base you can find on the internet and find a CV in it. That's not how you learn. And it can be very boring and it's time consuming. And the real problem is that that's a game of luck. And you may get super lucky, good on you, but you may get super unlucky. And you feel like you're wasting your time. What I recommend nowadays to people is instead of looking for a CV, analyze CVs. Look at those, and you're going to learn a lot of things. Do write-ups. That shows to an employer that you can understand how vulnerabilities occur, how they get fixed. You can talk about the fixes. You can talk about a lot of things. And it's a lot easier, a lot less stressful. It doesn't rely on luck at all, because the bugs are already there. It just relies on the time and the energy you're going to spend understanding the issue. And you're going to learn a lot, and you're going to get a lot better at spotting issues in the future. So if you're looking for a job in offensive security, try to do that. It's probably a lot easier and a lot more deterministic than just looking for a CVE. Conclusion. I told you we can do it. So we look at CVEs, hackers. They look for impact, exploit, vulnerable versions. Web developers, they look for impact, vulnerable versions. Do we have to patch that? That's basically the idea. The business, the business. I'm not mocking people in the business, but I find weird that we call something the business. It's like, the name is weird. They look at impact and how much it's going to cost to fix the issue. But not a lot of people are looking at the source code. If you're lucky, one researcher looked at the source code because they did a code review instead of just like a black box test. So that's one person. The maintainer looked at the issue. Maybe it's not a security, he doesn't have a security background, or she doesn't have a security background, so we don't know. But they didn't really, maybe not fully understand what is happening. And like a few nerds are looking at the diff. That's about it. And we're losing so much important knowledge because of that. And the same thing is like looking for the exploit versus looking at the exploit. Very important. Like, try to keep learning to get better. I can summarize that in one slide. Read code, receive bug. The more code you're going to be reading, the better you're going to be. And every vulnerability is a lesson. Like, how much time was? Yeah, good. I'm good. Oh, good. Like, I was making fun of the person from Queensland, but like, we shouldn't look at vulnerability like something that is shameful. We should look at that as lessons. I got a friend who is really good at social engineering, and he did like a social engineering gig one time, and like one of the managers was like, "Oh, this person got done. We should fire them." He was like, "No, this person is the most valuable person in your team now, because they know exactly how they got compromised, what mistake they made." And it's the same for vulnerabilities. When people create vulnerabilities, there's this sense of shame, they're bad developers, they don't know what they're doing. Sometimes it's true, but no, but like, it should be like, okay, let's learn from that mistake. Let's not blame people, let's not put shame on that. Let's say like, okay, is there something we can learn? Is there something we can do better? Is there like, why this function is named path.clean when it's not preventing directory traversal? That's weird. Why there is a function in Golang that does like SHA and like copies the value? That's something that people will get wrong. What can we learn from that, and how can we make AppSec a lot easier for everyone? So celebrate finding and fixing bugs, and look at a lot of CV, because it's a lot of fun. It's not that nerdy, I promise. Thanks for your time, and if you have any questions, please don't hesitate. Any question? Otherwise, I'm going to be around. Yeah. No? So everyone is going to look at CVs, I'm taking it? What's the vibe? Yeah. No, but really, like, I think it's really something, like, we got all that knowledge that now is really well and easy to access, well exposed by GitHub and really easy to access. And just like, instead of going on TikTok once a day or once a week, just pick one of those CVs. And just do that once a week, once a month, and I promise over time, you're not gonna eat gold all the time, but you're gonna learn over time. At least more than on TikTok, I can promise that. I swear. Otherwise, thanks for having me. And yeah, I'm gonna be around.
Easy. Thank you so much.
No worries.
Cheers, Luke.